familiar with the concept of memory or storage in any of the languages, they are most likely the same, right? So we can say to storing the value in Solidity, we use these three types of keywords, I would say, right? So the first one which we have is your memory, and the second one which we often use is your storage, and third one is your call data, right? So we have these three kind of storing values, storing keywords which you often use in Solidity. Now let's touch upon both three of them one by one. Now let's see what is memory. Now if you look at memory, you can find it similar. Let's compare this memory as RAM, right? Let's compare it with RAM. Now RAM stands for your random access memory, right? So the RAM essentially not stored your entire information. Essentially, if you look at the RAM can maximum can go to 16 GB or maybe like 32 GB, right? And the main function of RAM is to essentially not store the information for the long term, right? Let's say in your computer, if you look at the RAM, the main use case of RAM is essentially when you are surfing any web, right? Whenever you are multiple programs, if you have multiple programs running up in your computer, right, and you want to switch in between both of them, right? So these switch from one program to another program, it's done in a matter of seconds, right? And these storing values came from your essentially RAM, right? So you have to think of it in this way. Now the storage, we think of storage as a hard disk, right? We think of it as a hard disk wherein they have a high capacity for storage, but the retrieving power, let's say if you want to retrieve information from the hard disk, that thing is very low, right? A huge capacity, you will find your hard disk to maybe like 10 TB or maybe like 1 to 2 TB of data, right? So they can hold that amount of data, but high capacity for storage, but less but have essentially we can say high capacity for storage and but less what can I use right over here, but less power of retrieving the information, right? So yeah, we can use that. And the call data, essentially you can think of a call data as let's say, so this call data is really used, and these are like immutables, right? So once we allocate some sort of data in the call data by using call data keyword, we can't essentially change that, but if we declare that in the memory, we can change that afterward, right? So that's why if you compare now, these storage essentially stored now I will share you more, so like we can just add they are like immutable dash again the constants, right? And we can't change that once we declare that. Now let's touch upon these things in a more brief manner. Let's say first let's forget about call data for a bit of seconds. I will let you know about this, and this thing is really used, so we just don't look at this for a bit of second. Now let's talk about more your memory and storage, because you will see every time you will be using memory in your code base, right? So that's why you have to understand the memory and storage first. Now let's add a multi-line comment so I can essentially use more space, right? So now first thing first, let's try to understand what is storage, right? Storage, and then we have your memory. memory. Cool. So the first thing first which the storage does is essentially it holds yours, it's essentially, you can say, it holds your state variables, right? So yeah, they hold your state variables. And the second thing which it does is uh, it essentially store the information on the blockchain as a permanent, right? So we can't change that. So let's say store on blockchain, right? So we can't change that. Now look at the memory. So memory, essentially we can say memory, your it's does the same. It essentially holds your local variables. So if you're not familiar with the state variables and local variables or global variables, I already make a video in the series, so you will just check that video out. I will put the video link in the description, or you can just check out my channel. Cool. So now the first thing, it essentially holds your local variables, and essentially now if you're holding your local variables, that would be most probably defined inside the function. Let's say, so we know that essentially they can be defined inside the function, right? Defined inside the function. And now as we know that storage is permanent, but the memory is not a permanent. So essentially it's non-permanent, right? So it essentially stored the I would say code in the memory, right? So that's how it kind of works. And essentially if you're storing the information, if you're essentially storing the information on the blockchain, they are essentially more expensive because you're now making connection direct to the blockchain, right? So you need to pay more gas, let's say I can add pay more gas, and more expensive, I'd say expensive, right? And now you're not storing it on the blockchain, hence your memory is it's going to be less expensive for the gas fee, right? For gas, right? So these are the broader aspect of what's differentiate between your storage and memory. Now we can also, now as I already mentioned, that you can think of it as a RAM, and you can think of it as a storage, or maybe like as a hard disk. Cool. So let's make a function and test that which function will take which keyword will take more gas. Let's say make a function for memory, and it's gonna be public, and then what we want is need to pass some sort of parameters, right? So let's say add a parameters of string of name, let's say, and they should be allocated in the memory, and then we're gonna be passing a uint. It's gonna be a array memory, and let's say array, what's the address, let's say add adding something. Instead of adding, let's say add a keyword for age, right? So we have this memory that takes in string of in the memory of name and uint of this. Now let's copy this and see the same for CallData. CallData should use this, instead of memory they will use call a data, right? So just compile this, and I will not using storage right over here because you need to use storage outside of your function. So I will just let you know why I not specify another function with storage keyword right over here. If in case if I do that, it will throw an error. Let's say if I essentially use storage and just make this function as storage, and let me I'm just essentially change these because maybe like we need to have them. Username, age, old. Let's add a name one, and let's say wait. Okay, right. So now if we compile this, now it essentially give us an error because of this thing, because I already shared with you that why you don't need to add storage right over here. If you look at the error, it says that data allocation must be a memory or call data for the parameters in the function, right? Yeah, that's why it's giving us an error. We don't need to specify storage inside of a function, right? So that's why I will let you know why do we need. So instead of the storage, we can add we can easily add let's say instead of this adding the storage right over here, what you can do is we can make an array right over here. So I will let you know afterward. Let's say just first test these two, call data and memory, compile them, and again deploy this. And now we need to essentially look up the gas fee, so which one takes more gas and all kind of stuff. Deploy. Now once you deploy the contract, you will see these are the two functions. So this is the call data one, and this we have right over here is the memory. Now I will already tell you that memory essentially holds your local variables defined inside the function. These are not permanent, this is permanent, and this will take less expensive for gas, like, as compared to storage, right? So we have call data, so we know that call data holds your data essentially for the long term, right? So that's why we need to add that. So let's say add a string of my name. Let's say add arrays of 1 2 3 4 6 7. So once we have both of them, let's just essentially transact this and just try to expand the call data one. So if you look at the gas essentially is this gas, right, for the call data one, and just essentially got them gas for call data function. So we have this. I think it's in way, so that's why I just add gas. And again let's say transact this memory one, and now this memory one essentially transacted, and you will see that the gas for this is essentially more expensive, right? This is essentially more expensive gas for memory, because we have this gas, right? This is essentially more expensive than the call data, because call data stores its permanent, and then it's not stored permanent memory, and hence the gas for this is huge, or let's say a bit more than this one, right? Now let's say use memory. Let's say I will let you know how we can use memory, how can use storage, sorry, in this Solidity. So let's say just remove these things just for now, right? And now what we need to do is we need to send. Now let's see the implementation for your storage, right? So for the storage thing, let's say make another contract. So say make contract for, let's say, main storage, and this contract would essentially, we can say this contract takes a int. That int is going to be a number. It's going to be a public one and going to be a number, right? So then let's say make a function. Let's say make a function. This function essentially just make it a number, right? So yeah, so we need to public right over here because we want to, okay, we want to view that, right? So you have this function of numbers or public, right? Then we need to essentially push the, let's say we have this numbers dot push, and we're gonna pushing the number 1, and then let's say make a numbers dot push, and this should be your 2. Cool. So yeah, make sure that you add a semicolon at the last so that people can easily recognize that. So next thing which we're going to be using is, let's just essentially create a new instance. Let's say make a int, okay, let's say make a int of let's say storage, right? This would be storage, right? And the storage is, let's say give it a my array, right? And this should be equals to the numbers, right? Then again, let's just add the value to the final index with this new index. Let's say we can add this my array of index 0. Let's say index 0 is equals to, let's say 0, right? So what we does is we are essentially storing the index of 0 as 0, right? So now let's again compile the contract and delete this one, and so we have these two storage. Let's say this main storage, and deploy this, and you will see, let's first essentially call this, and yeah, every time if you look at the numbers, like this number 1, so in Solidity or in Remix itself, the buttons which have this brownish color cost you gas, but this kind of button doesn't cost you gas, right? So if you look at this numbers, right, so once we call the numbers function, and if you look at the expand the transaction list, and if you look at the gas, right, so gas fee, yeah, so gas fee is here, so the gas fee is huge, right? So let's say gas for storage is close to around this, right? This is the gas, right? So if you compare that with the memory and then with the CallData, storage takes a lot of gas, right? And yeah, that's everything for this video.